Our second and final objective for 8.4 is going to be to solve applied problems using quadratic functions as models. So again, I'm not doing all of the applications we could do. There was area ones, which I was all excited about, but they took them to a different level. So the only two applications you'll be asked is the Pythagorean theorem ones and these applied problems. I mean, there was questions in 8.6 that had area, but they were the traditional ones, like the length has to be, 4 more than the width, or the perimeter is. The ones in 8.4 kind of went nutty. So these questions, we're going to solve applied problems using quadratic functions as models. And what that means is that they're going to give you the equation, which is kind of nice. And then we are going to solve for things within the equation. So for this one, it says if a ball is thrown upward from the ground, the equation to find the height of such a ball thrown with an initial velocity of 80 meters per second is. So what they're giving you here is they're giving you height as a function of time. And so the ball is going to go like this. Now in 8.6, we would have found, hey, what is the maximum height the ball could go, and at what time was it at its maximum height? Whereas in 8.4, we're going to be asking more things along the ground or anywhere that there can be 2 points. So for example, we're going to be asking, find the time it takes the ball to reach a height of 48 meters. So I'm going to assume that that's not the maximum. I'm going to assume it's somewhere up here, and we're going to be solving for the 2 times that the ball is at 48 meters. So if we do that, the equation is height as a function of time is equal to 80t minus 16t squared. Now that's way too many variables. So what they will always do is give you the height. Okay, so they're saying find the time it takes the ball to reach a height of 48 meters. So we're going to put 48 in for h of t, and then we're left with 48 equals 80t minus 16t squared. Now, this is a quadratic equation for us to solve. We can try factoring, we can square root property, we can complete the square, and we can quadratic formula. But no matter which one, the first thing I would do is move everything to one side. I don't like dealing with negatives, so I'll just move it to the other side. So I'm going to add 16t squared to each side, and I'm going to minus 80t. Weird, I said squared and I think I wrote an S because of it. So I end up with 16t squared minus 80t plus 48 is equal to 0. If I'd moved everything to the right, which would have been just moving the 48, it would have seemed easier, but then I'd have a negative and blah, 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 blah. So either way will work. Then what I always check is, could I get rid of the 16? So because it's equal to 0, I'm able to divide by whatever I want. So I'm going to divide everything by 16 if I can, and I'm pretty sure it does. So I'm going to end up with t squared minus 80 divided by 16, which is 5t, and then 48 divided by 16 is 3. If you didn't divide by 16, that's fine. You can do it with these numbers. They're just huge because now I have 4 choices. Factoring. There aren't 2 numbers that multiply to give me 3 and add to give me 5, right? 3 and 1 would make 4. Square root property, there's a t term, can't do it. Complete the square, that's an odd middle term, so I don't want to. I could, I don't want to. So I'm going to use the quadratic formula. So I'm going to say t equals, and the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to fix that 4. I must drag my hand or something. Okay, so my a is 1, my b is negative 5, and my c is 3. So we're going to plug in negative 5 makes that a positive, and then negative 5 squared minus 4 times 1 times 3, all divided by 2 times 1. And then we simplify. So we end up with 25, 4 times 3, 13. So I've got 5 plus or minus the square root of 13 all over 2. Now, this question said that I'm allowed to solve to one decimal place, so now I'm going to look at my two solutions. One of my solutions is 5 plus root 13 all over 2, and my other solution is 5 minus root 13 all over 2. Plug these into my calculator. So the first one I'm going to plug 5 plus root 13. Make sure you hit equals or you put the entire numerator in brackets. So this has to happen before dividing by 2. So I'm going to put 5 plus root 13 equals, divided by 2 equals, and to one decimal place I get 4.3 seconds. Then I'm going to do this one. 5 minus root 13 equals, divided by 2 equals, and again to one decimal place I get 0.7. So what that means is that if you think back up to that picture I did above, right, we're looking at height as a function of time. My graph looks like this. I said at what height or at what time will my height be 48 meters? We just found that it's 0.7 seconds and at 4.3 seconds. Okay, so there's 2 because it's a parabolic shape. It's a mirror image, or it's got symmetry. So therefore, it will be at 48 meters at 0.7 seconds and 4.3 seconds. Now, they can do variations of this question, so they can say a height of anything. They could also say on the ground, or how long will it be in the air? And then for these ones, the only trick is for both of those, h of t would equal 0. So that's actually kind of a nice one. If we get to put in 0 for h, then we could have just factored this one as a greatest common factor and gone for it. So most of the questions will say, you know, when will it be at a specific height? But if it ever says how long will it be in the air, or when will it be on the ground, put in height as 0. The second question here is not the same sort of idea, but I put it in just so you don't forget because we haven't done it in a while. At what time will the ball reach its maximum height, and what is the maximum height the ball will reach? So again, this is not 8.4, but I just feel like it had been so long that I don't want you to forget that there's two different things we did. So again, my equation is h of t is equal to, what is it, 80t minus 16t squared. So we just spent a whole whack of time using factoring, square root method, completing the square, and quadratic formula, and that solves quadratic equations. This, what's bolded, maximum, maximum. So for this question, we're finding vertex. We cannot use factoring. We cannot use square root method. We cannot use quadratic formula, although we could use completing the square. So up to you. You're going to first of all rewrite your equation in the right order. So I'm going to put this as negative 16t squared plus 80t. Up to you. You could complete the square for this to find the vertex, or you can use the vertex formula. I'll do both just because it's a good reminder. So I'll start by completing the square. So for this one, you can't divide everything by 16 because it's not equal to 0. So I'm just going to take that negative 16 out of the t squared in the t term. I'd be left with t squared, minus 5t. Maybe I don't want to complete the square. I'm going to do it. If I was you, I probably actually wouldn't, but just to show you that you can. So to complete the square, right, the magic term is half the middle term squared. So it's just a fraction. It's okay. It's 2.5 and then you square it and we get 6.25. So use it as a decimal. That's okay. So whatever you add, you also have to subtract. I should have put a nicer example. Then we only want the positive for my perfect square trinomial. So I'm going to take the negative out by paying the toll. I end up with negative 16 times t squared minus 5t plus 6.25. And then I've got negative 16 times negative 6.25 out here. And then I factor. I wasn't that bad, right? So this would be t minus, just put 2.5, right? Half the middle term, or the square root of this term, squared. And then I've got 6.25 times 16. Sorry, someone's sharpening a pencil. And I get plus 100. This would tell me that what? My vertex is 2.5 and 100, which says that at 2.5 seconds, that's my time, I would have a maximum height of 100 meters. So you could go from that. Most people I feel like wouldn't have completed the square for that one. So let's use the formula. The formula is t equals negative b over 2a. Right? That's the x value of the vertex. So negative b would be negative 80 over 2 times negative 16. And then I plug that in. So 80 divided by bracket 2 times 16 or divided by 2 divided by 16 negative, which gives me 2.5. Same, same. And then to find the maximum height, you put in t is 2.5. So into whichever equation, let's put it into the original. So 80 times 2.5 minus 16 times 2.5 squared. So I get 2.5 times 80 minus 16 times 2.5 squared. And again, this is just a reminder of 8.6 because it feels like forever ago. And the fact that you could have the same equation and do two different things with it. You could use it as an application of the quadratic formula, or you could use it as an application of the vertex. Either way, we'll say therefore at 2.5 seconds, the ball will be at a max height of 100, what units am I in? Meters. I feel like that'd be really high. All right, so again, that was just a review of 8.6. The questions in 8.4 will be like this first one, where you have to factor or complete the square or quadratic formula. All right, good luck.